Hey everyone, I'm back again. So today we're going to look at Science Paper 1, 2023, Section C, Question 1. So this is the question here. So it's saying table C 1.1 shows a force and acceleration of a box recorded while being pushed along a horizontal surface by a learner. So that is a table that we have a force, we have the numbers for force there, and we also have the readings for acceleration. So the first question here is saying define a force. So this is how we define force. So a force is a pull or push on an object or on a body, as simple as that. State Newton's second law of motion. This is how we state Newton's second law of motion. It states that acceleration is directly proportional to force and inversely proportional to mass. So this is the answer for question B. Okay, so this is one for question 1. Question B. Let's go to C. C is saying plot, comma, on a graph paper, comma, a graph of force against acceleration in meters per second squared. Okay, so we're going to do some work. That is where we are having some work to do here. Okay, so I'm going to push the question paper here, and then I'm going to bring the paper, the graph paper where I was doing some work on. So this is a graph. So this is a graph that we plotted. The first thing that you should do when you are working with a graph, let me take you through the steps. The first thing that you should do, learners, is that you should be able to understand this point. They are saying plot on a graph, plot a graph of force against acceleration. So which means this side we're going to put the forces, and then this side we're going to put the acceleration. Okay, so this is force against acceleration. The second thing that we're going to do, you're going to look at the table, and from the table you're going to decide which scale is going to work for you. Which numbers are you going to put here? Okay, and the numbers you're going to put here, so that we can bring out a perfect smooth graph. In this case, looking at the results that we had in the table there, on forces we have 0.00 followed by 0.25, 0.50. So what I did was, on force, on the side of forces here, I had chosen a scale which was running to from 0 to 0.25, 0.50. So I'm adding a 0.25 on each. So this is 0.25, 0.50, 0.75, 1.25. So that is the scale that I chose. On the other side here, it is easy. So I chose a scale which was running from 0 to 5. So I just said 1, 0, 1, 2, 3, 4, up to 5. So after doing this, let me show it, the whole part of it. So after just, without this thing that I have drawn here, just writing these numbers here and these numbers, and also indicating that this is acceleration, meters per second squared, and this is force in newtons, in a pencil. So when we are writing a graph, we use a pencil. I'd used a red pen so that it can be more visible. But in your case, when you're writing an exam or you're doing work that you're supposed to submit for marking, you should use a pencil. So just by writing these things here in a pencil, you get a mark. This is how we mark graphs. Okay, now from there, ladies and gentlemen, we have coordinates here and there. We can now plot a graph using the table. Okay, so let's go back to the table. So this is what we are having on the first here. So we have 0.00, comma 0. So you are coming on the graph here and then plot 0 on the x-axis here, and then 0 on the y-axis, which is going to give us this point. Okay, Let's go to the other one. The other one is 0.25 comma 1. So these are coordinates. So we are going to say 1, the one that starts first is the x-axis. So we're going to say 1 comma 0.25. So this is the point. 1 comma 0.25. This is the point. The other one is 0.50 comma 2. So that is 2. The 2 is the one that starts first because it is in the x-axis. And then 2 comma 0.50. Okay, you do the same to the next 3 comma 0.76. So here we are having a bit of a challenge. So this here we have 0.76 and then 3. So we're going to say 3 comma 0.76. So look at what happened here, what I did here. So this is 0.75, but on the graph there we are having a 0.76. So I had to push it a bit further there. Instead of making it to sit on where these two lines are meeting, I had to push it up there so that I can follow the readings correctly. Okay, so this is how we are moving. So we go to 4 comma 1. So we are here on 4 comma 1. Where is 1? 1 is up there. So this is a point. And then we also have 1.25, 5 comma 1.25. So we are coming to 5 here, and then we are going up there to 1.25. So we have a 1.25. So this scale seems to be working out. So after doing that, ladies and gentlemen, you can now draw a smooth line connecting these points. So just draw a smooth line. Please don't use a ruler when drawing the lines. Just use your free hand. Okay, so that's how we draw the graph. The first thing is to come up with a scale. The scale is going to really help you, and also understand that these, look at them as coordinates. Okay, let's move on. I don't want to waste much of the time. Okay, so now we've drawn the graph. Let's go to the other question, which is saying determine the gradient of the graph. Okay, so what is the graph? What is the gradient? Gradient is simply the steepness of the line. So this is the line that we have. They are asking it, so can you give us the gradient of this line? Okay, so what do we do for us to calculate the gradient? The first thing that we do to calculate the gradient, ladies and gentlemen, is to pick 2 points on that straight line. Just pick any 2 points. We're not going to pick this point because it is not proportional to acceleration here. All the points that we had drawn, they were landing somewhere in between these 2 lines, except this one. So when you are picking the lines, please bear in mind that this one, don't touch it. Something happened here that we don't know. So just pick some line, the points that were landing on 2 straight lines like that. Okay, so that is the point. So we can pick this point and this point to find the gradients, like that. This is the one that I picked. Okay, but you can also pick this one as well as this one up there. It will give you the same answer. Or you can pick this one as well as this one. It will give you the same answer. Okay, so we are just picking the 2 points. Okay, let's go for this one. So this is 1 comma 0.25. So we've written this one as a coordinate. 1 comma 0.25. We've put this one as a point. So let's go to the other one. So we are also picking this one, which is 2 comma 0.5. Okay, so we've picked this one. So these 2 coordinates, get them and then put them on the formula. So we have a formula here. Gradient is equals to y2 minus y1 over x2 minus x1. So these are the points that we had picked. Okay, so these are the points. So after picking those points, we can give them names. So this is x1, y1, x2, y2. From there, we can substitute these into this formula for us to get this one, because we know that y2 is this one. So this is 0.5 minus y1 is y1 is here 0.25. So I just got these and substituted them in the formula. So I got this. So when you subtract this using a calculator, you're going to have 0.25 and then over 1, because you're subtracting 2 minus 1. So to get this one, so this one was the gradient. So this is the gradient. Whatever 2 points that you meet, you pick, you're going to have that. Okay, so if you have any question, any further clarification, please don't forget to write them in the comment section. So let's go to the other question. So we'll find the gradient. So they're saying E, so we're going on letter E. So we're saying, what physical quantity does the gradient represent? What physical quantity does the gradient represent? Ladies and gentlemen, by looking at this formula, this nature of a question, so not formula, but this nature of a question, we've been given the force, we've also been given the acceleration. From this question, we were asked to state on B, to state Newton's second law of motion, which we stated to say acceleration is directly proportional to force and inversely proportional to mass. Okay, so the physical quantity that they were the gradient was representing here is mass, from where Newton's second law of motion. Newton's second law of motion, this is where this is a formula that represents Newton's second law of motion. Okay, so if we had this and we also had this, acceleration and force, so the one thing that we were looking for was the mass. So the gradient here was representing mass, so we can leave it in kg. So you can just say mass, that is the physical quantity that the gradient represented. Okay, let's go to F. Okay, let's go to F. From the graph, determine the force that produced an acceleration of 3.5 meters per second squared. From the graph, so we're going to come to the graph. Let's come to the graph here, and then we have been given acceleration of 3.5. So you come here and then just land yourself on 3.5. This is 3.5. Okay, so you are on the acceleration of 3.5. So you want to find the force that's produced this acceleration. So what you're going to do is you're going to put your ruler there and then just draw a straight line that is going to hit this line. After hitting this line, the point, make a point here and then draw a line, okay, which is horizontal. Okay, horizontal line. Where this line is going to pass is the force that produced this acceleration. Okay, in this case, this force, according to my calculation, was 0.8875 newtons. So this was the force. It was 0.875 newtons. Okay, how did I do that? So from 0 to 0.25, we have 10 divisions here. Okay, so what I did was, for me to know what each division represented, I divided 10 into 0.25. okay, after dividing, it gave me something like 0.025. so each division was representing 0.025. so what I did was, from here 0.75, I counted how many divisions, 1 2 3 4 5. So since each division is representing 0.025, I multiplied 5 by 0.025. okay, so that answer that I got, I added it to 0.75 for me to come up with this answer. Okay, thank you very much for being here. Thank you very much, and remember to subscribe.